Good morning. This is the webinar number 6, and we're going to talk about fake objects and the mocking in general. A few words about mocking just to give you an idea of what it is, but I hope you understand how it works and what it's for. In a nutshell, when you have an object, a class, well, an object, an instance of a class, and another class depends on this object and wants to use it somehow, then to unit test this second class, you don't want to create a real instance of a real object of the first class because there are some, real-life production dependencies which you want to avoid during your unit testing. That's why you need to create some kind of it's called a mock version of this class. So you want to mock that class and create some sort of a fake instance of that class, which is not the real one, but which will look like the real one. And then you pass this object to the class you're testing, and then you can more or less safely test the interaction between your main class and this fake and this mock instance. I hope you understand that. I'm not going to go deeper, but there are a few problems with mocking in general. That's why, because of them, mocking is considered, and I agree, mocking is considered as a bad practice and as something which you should use only in some specific situations, but not always, and in very rare cases. So there are a few problems which mocking will cause for your entire code if you keep using it everywhere. And I'll explain what these problems are a bit later. But now let me show you. But today we're going to talk about fake objects, which I think is a good replacement for the mocking, for the traditional mocking technology, which is given to us by Mockito, for example, or JMock, or many other frameworks, which are designed to help us mocking our classes. So I believe these frameworks are not really the best practice. It's more like a last resort. You should stay with only in specific cases. But in general, instead, you should use fake objects. And I'll explain what these fake objects are. But let me show you an example first of a real library which is using this approach. Let me share the screen, which demonstrates what I'm talking about. So first of all, we have a library called JCabby GitHub, which is a library that abstracts GitHub API. So GitHub provides an API, a RESTful API through HTTP interface, and we created a library which allows you to interact with this API in an object-oriented way. And this library has about 100 interfaces. Look, this is the list of interfaces in the library. It's almost 100 of them. Everything which starts with the I letter here, it's interface. So these guys are interfaces. Each of them is an abstraction of certain entity inside the GitHub API. For example, look at the issue, for example. So the issue is it's an interface. So the issue is a GitHub issue, and this interface allows you to, for example, get a number of this issue, or get all the comments from this issue, or get all the labels or events, or check whether the issue exists. That's all. And also it allows you, a few things, but the point is that there are about 100 interfaces in the library, and also about 100 classes which implement this issue, these interfaces. So look at this. All of them start with the RT prefix, which means runtime. So for example, this is the interface issue, and we have RT issue. There you go, this one, which is a runtime implementation of the issue interface. And so this class actually makes the real HTTP calls to the GitHub API, and it checks what's going to be the status of response. It checks, like it does real HTTP interaction with the GitHub API. So this is the interface. This is the class. But On top of that, we have a collection of, we have another package. And in this package, we have a collection of classes which start with the MK prefix, which is for mock. It could be FK. Now I'm using FK, but I was using MK like last year. So mock or fake doesn't really matter. But the point is that these classes, there are also about 100 of them, as you see. 100 of classes here, and they all have, again, same names, but a different prefix. So instead of the RT prefix, it's MK prefix. So look at the class MK issue. So MK issue is a mock GitHub issue. It's the class which implements the same interface issue, the same way the RT issue is doing. So RT issue implements the issue interface, but it does it the way to, in a real way, so that the connections, that the interaction is happening directly with the GitHub API through HTTP interface. But in this case, the MK issue, it also implements the issue, but it doesn't make any calls to any HTTP endpoints, to any servers, to any GitHub API, but it does some internal manipulations with the data, so that on the surface, it looks like an issue. It looks like a GitHub issue. So this object can be used, this MK issue can be used everywhere where we need to use a GitHub issue in other. So this is the library. This is an open source library which you download. It's Java library, so you download it, use it in your project in order to connect your classes to GitHub API. And then in your code, you will have to have an instance of this interface issue. So you will want to have an instance of interface issue in order to connect your class to GitHub. And in production code, you will use RT issue. But in the unit testing, I will show you right now how it works. I'll show you the real project, which is using this library. So in production, in real code, you will definitely use this class. But what you're going to do in the testing, in unit testing situation, in a traditional approach, in a very common approach, like what many people are using, they would just mock this interface issue. They would just create a mock version of it and then use it. But I'm saying that this approach with the MK issue is way better. And now let me demonstrate how it's all used in the real situation. So now let me share you another project, which is Rulter. Let me show you where it is. So here's the Rulter project, which is, it's also open source, so you can check it online. So this project is actually connecting to GitHub API. So it's actually, making this, using this library, which I just showed you. This project is using the library in order to connect to GitHub API. And this is the code, for example, this one. So this is the code which is expecting, like, look at the one method. Doesn't really matter what's around, but this one method which expects, this is the comment, this is the comment from GitHub. So this method is supposed to understand the comment just posted to GitHub. This is the class called comment. So this class, this interface actually is coming from that library I just mentioned. So this method, which is named understand, it expects two parameters. The first one has to be the comment from the GitHub, and the second one is home. So this method will do something with this comment, understand what's there, and post something back to the GitHub. So we call this, not we, but in this Rulter, somewhere inside, somebody will call this method, pass a comment just posted on GitHub, and this method will understand, will process this comment somehow, and post an answer. And say, okay, I got your comment, I got what you just said, and here's my answer. This is the production. This is production class. The class will do something, build something, blah, 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 post. It doesn't really matter. What matters is that the parameter of this method has to be a comment from GitHub. So the question is, how do we unit test this method? In order to unit test it, I have to pass, okay, the URI, it's not a problem. I can just make an instance of URI and pass it there. But what can I do with this? I really need to post a comment there. I need to give this method a comment. So my first option is basically to mock it, but this is not the best option. So look at how we are doing it instead. So this is how it looks. This is the call to the method understand. And here I'm sending a comment to it, but where I'm getting this comment, I'm just getting, okay, give me the, I'm using this issue object, and I'm getting all comments, and I'm getting the comment number 1. So it looks like I'm working like with the production instance of GitHub, because this is real issue. Well, it looks like an issue, and then I'm getting all comments, and then I'm saying, okay, give me the first one, and I'm passing it, and I'm just wrapping it in this decorator, and then I'm sending it to understand method. So how do I create this? Where did I get the issue? Let's look up. This is how it works. So first of all, I create an instance. I can make it longer to be more clear. So first of all, I create an instance, a mock version of GitHub. Again, look at the prefix. It's MK GitHub, because there are many like classes, and this is the hierarchy of classes, hierarchy of instances. So this is of interfaces. So this is the interface of the highest level. So GitHub is the interface which I'm supposed to create. So in production code, I would do it like this. This is how would the production code look. And here I would give my credentials and say this is my password. This is how the production code would look. But I'm not in production now. I'm in unit testing, so I don't do that. Instead, I'm doing this. I'm creating the mock, or the fake version of the GitHub. This is the class provided to me by the library. But it's not mine. I'm not creating it here in this Rulter object or in the Rulter project. It is created and provided and shipped to me together with production classes, together with RT GitHub. So these two guys are shipped to me together, the RT GitHub and MK GitHub. But now in unit testing, I'm using MK GitHub. Then I want to create a repository. So I'm doing this, final repo equals. So now I'm interacting with this GitHub the same way I would interact with the normal production, GitHub API. So I'm making new repo, create, let's say test private false. So I'm making now in this line, I don't really know that this GitHub object is a fake one. I'm just creating a new repository. I'm saying, okay, give me all the repositories, then create the repository for me. This is the configuration of how this repository has to be created. Something like that, and now I have the repository. And the next step, I'm saying repository issues, create a new issue, and then I can say my new title. This is the body of the issue, and again the issue is created. But I'm not working right now with production GitHub API. You see, I'm just interacting with this fake object, which internally implements all this functionality. So it behaves like GitHub for me. It keeps all this information, all this data somewhere in files or in some local database. I don't really care. What I care about is that it behaves externally, like the real GitHub, like a real repository, like a real issue. And then I want to post a comment to this issue. I'm saying issue, comments, post, status. Or I can say issue, comments, post, how are you? And it happens like I'm talking to the real GitHub. I'm staying on a unit test. I'm interacting with this set of objects, and I don't really know that I don't really see that they are. I'm not mocking anything here. You see, there's no Mockito, no JMock, nothing like that. I'm just working with a fake implementation of the real life interface. And then I'm saying, okay, issue comments, get me the comment number 1. So I'm getting the comment which I just posted. So I posted the first comment over here, and here I'm saying, okay, give it to me. the comment number 1. I'm using number 1, not 0 here. You may ask why 1, because number 1, this is how GitHub, well, this is, I think this is because this is how GitHub, I don't really know why, but this is the internal numbering of the comments. It doesn't really matter again. So this is the first comment here, and I'm getting it. And then I'm running this. So I'm running this function understand, and as I said before, this understand function, this understand method is supposed to say something back to the GitHub issue. So it gets the comment, it processes, it answers something, and then I'm checking, I'm making the assertion here, I'm getting the second comment from there. So I just executed the method understand, and I expect this method to post another comment there. And I'm getting comment number 2, and I'm getting the body of it. And then I'm saying, okay, it needs to contain this string, and this string, and this string, and that string. So this whole unit test will just run. You can run it and see how it works. I'm running now. So it works. So look what's happening. The MK wrapper, it's also sending the logs there. So these fake classes like repos, issues, comments, they all, you see MK. So they're all from this package. And they're telling me what's going on. They're saying repository Jeff, you see, somehow it's Jeff. So because this is fake, so internally it says my name is Jeff. Okay. So it doesn't really matter, but this is the default. And then it's making the repository with the name I just given. It says repository this one created by Jeff, somewhere internally in files probably. And then it says issue number 1 created, boom, and this is the title of the issue. And then it says comment number 1 posted to issue number 1 by Jeff, status. That's right, that's the comment, status. And then we executed the method understand, and it says comment number 2 posted to issue number 1 by Jeff, and some text here. Boom, something going on, some links, some text, everything is fine. And then status request number 1, this is the log from the class under testing. So we're actually testing this class. But all this scaffolding, which happened before these 4 lines, it didn't happen, well, actually 3 lines. That was the scaffolding, these 3 lines. So we didn't do anything with the mocking because this approach is way more convenient and way shorter and much more understandable by me as a programmer. So this code is really clean for me. I know what's going on. I can see it. So I prepare this fake object in a normal way. Instead of doing, we can try to replace that with mocking using Mockito, and you will see how ugly it will look. Because, for example, here instead of, I need to pass the comment object, right? So I may say that, look, instead of this code, I'll put the comment here. Now I need to create the comment. So I'm saying comment equals to Mockito mock. Okay, sounds good. I can run it, but we will see the problem because it's not going to work because this mock class will produce a null. So the class, the instance of class comment. So now the question is like, what's going on? I'm trying to mock it, and now I see issue is never null. Okay, I'll go deeper inside and see, okay, probably, because I know how this library works. So I just understand that, okay, the problem is that we need to do something like, we need to create, let's comment this out for a minute. We need to create an issue also, and it also has to be a mock of an issue class. And then we need to make sure that we return the issue when comment, comment when somebody will ask for it. That's the problem. So somewhere inside, I just understood it because of the stack trace. I realized that inside this method, something is happening, and this method internally is trying to get an issue out of the comment. Because well, it has to answer probably to the comment, and that's why it needs to get an issue out of it. So okay, I realize that probably something internally is happening, and I need not, and now by default, the Makita by default returns null. So instead of null, let's return a mock version of issue. Let's run it again. Let's see. Maybe it'll work. No, it's not going to work. Again, null pointer exception. Where it's not null pointer exception? I have no idea. So I have to mock. Okay, let's go deeper inside and see. Okay, null pointer exception is here. Issue comments iterate. Okay, so when I say issue.comments, and then it says iterate, so probably the issue has to return a list of comments. So I'm saying Makio do return. Let's return something. Let's return an empty set. Empty list of comments when issue comments. Okay, so to avoid the null pointer exception. Okay, let's run it again. Again, wrong type of return value. Empty list can't be returned to comments. Comments should return comments. Okay, that's my fault. So it has to be comments here. So we need to create another comments. Makita. You see how complex and absolutely not clear the code is becoming. It is clear for me now a little bit while I'm writing it, but a few minutes later, again, null pointer exception. Let's see what's going on. Okay, here's the story: issue, repo, GitHub, user, self-logging. This is the set of calls which is happening internally. So the issue has to return repository, and the repository has to return GitHub, and GitHub has to return users. So now we need to create 5 mock objects in order to, to get rid of this null pointer exception. So I will create, sorry, I'll take a few more minutes of your time just to demonstrate how ugly it's going to be. Repo. Then I say, okay, return repo from issue when repo. Okay, that's fine. But now I need to say, okay, let's create GitHub too. This also has to be returned. Return GitHub when repo GitHub. And then I have to continue and continue. And I don't really know when it's going to stop because I don't know what else is happening inside this method. How else this method is going to interact with the GitHub library. And this code, which you see here, to me, it looks like absolute complete mess. It's not going to be clear in a few days to me. It's not going to clear in a few minutes to me because now I don't really know what this line is for or what that line is for. To understand this every line, I need to basically run through the whole thing again and go through line by line and understand, okay, so we need this comment because in the issue we need, this is the problem. So that's how we're getting, that's what I wanted to explain in the beginning. So this is the first problem of the mocking approach, is the real messiness of the code. So the code is absolutely not clean. It's not because Makita is a bad library. Makita is really like well-designed library. This is the best of all the mocking libraries because the syntax is, well, it looks okay. It looks normal for this use case. But the use case is absolutely not suitable for mocking, because look at this code and look at that code. This code is going to be clear for me in a year, in a month, in a year. It doesn't matter, because this code is absolutely, it literally reproduces the production, the real life interaction with the GitHub. So it's not for testing only. This is for testing only. This only makes sense in the unit test. But this one, the first example, makes sense in production code as well. That's why it's easy to understand. This is the first problem. The second problem is that with mocking, is that this code will become way longer, like I just explained. I will have to mock and mock and mock. So this code will be way longer, and this code we will have to reproduce in every single unit test. So every time we're using this GitHub library and we need to mock it, this amount of lines, or maybe more, we will have to copy it from unit test to unit test. So the mass will grow, and the amount of code will grow significantly. And I've seen unit test methods, unit test scripts, which are like, I don't know, 100 lines of 100 lines, 200 lines in length, and most of these lines are just mocking and mocking and mocking. So this is the first problem, is messy code. The second one is code duplication. The code is being duplicated everywhere. The problem number 3, and this is the biggest problem, the hugest problem, is that this code actually makes actually hard codes the assumptions which I just made about the implementation of this method. So while I was testing, I was just doing it in front of you. So while I was testing this method understand, I was looking inside of it. You saw how I did it. I saw the stack trace, and I was clicking there in order to understand where this null pointer exception is coming from. And I made assumptions. That's happening because this particular object is not mocked, or this method is returning null. So I was looking inside the implementation of the method understand. And I made assumptions, and then I put these assumptions over here. Why it's bad? It's terrible, because tomorrow, if I want to refactor this method, I will go inside this method, I will change how it works, I will change how it interacts with the GitHub library, and this unit test will stop working, will not work anymore. Because the unit test assumes that the method under testing is implemented in a certain way, which is absolutely not what a unit test can do. A unit test should not make these assumptions. A unit test is only testing the surface of the method. It gives you the arguments, you do something with the arguments, and you return me the results. I shouldn't care how you do that. I shouldn't care how you implement your functionality, how you implement your logic there, what's the algorithms, and how you interact with these objects. But as soon as I make these assumptions here, then I'm in a big trouble. Because this unit test is kind of it's not doing what unit tests are supposed to do anymore. The unit tests are supposed to help us to do refactoring without any fear to break anything. So I should be, ideally, in a normal way, I should be able to go here in this method understand, go inside, change whatever I want, and then run the unit test, and the unit test still passes. And I say, oh, cool, my refactoring works. Let's just put it to production. But in this case, in this situation with the mocking, I'll go inside, I change the implementation, I run the unit test breaks. But not because I broke something, but because I changed something. I just started to use the GitHub library in a different way. Still legal way. It still should work. It's not gonna work because I put this, because I not testing the functionality, I'm testing the implementation details. I'm testing not what you do for me, but I'm testing how you do it for me, which is wrong. This is not how unit testing should work. So this is how unit testing should look. So I make all these objects for you, and the implementation of this mocking, of this fake, all these fake details are hidden inside these MK classes, which are in the same library with the real time, with the production classes. So now, if my method understand will change the way, let me comment it out. If the method understand will change the way it works, so now I can easily change what's happening here. And no matter how I interact with the GitHub, this library, this library which is shipped together with production code, will fully support this interaction. So I can fearlessly, without any fear, without any being afraid to break anything, I can refactor this method. And no matter how I interact with this GitHub library, it's still gonna work. So that's my point. I think I'm probably finished. So that's my point. So the fake classes, I call them fake classes. So in new libraries, I call them FK. So the prefix is FK, not MK, but FK. It doesn't really matter, but you got the point, I think. So this has to be a collection of. Let me stop that. So this has to be a collection of. And let me start a QA. So this has to be a collection of classes which you ship together with your production classes. So you create if you design a library. So you create an interface, and then you make an implementation of this interface, which people are using in production, and then you create a fake implementation of the same interface, and you ship them together. Basically, you ship 3 of them: the interface, the implementation, and then the fake implementation. That's how you allow your users to use your library without touching the mocking frameworks. And this is not what, I haven't seen libraries doing that so far. I'm doing it only in my library, so maybe some other people are doing the same. I just haven't seen that. But I think this has to be a normal practice. So every time you design a library, you design a library which works, and also you design a supplementary set of classes which help me, your user, to test, to use your library in unit testing. So this has to be the job of the author of the library. It shouldn't be the job of me as a user, but I have to be able to get the library and see, okay, this is how it works in production, and this is how I'm going to use it in testing, in unit testing. Okay, oh, this is supplementary classes. I have the supplementary fake classes for this interface, for that one. Okay, there's no more mocking. I just use them, and they work like production classes. They pretend to be production classes, but they're not making any calls to any production servers or whatever. And in a few libraries, I use this approach. In a few libraries of mine, I'm using this in JKB Dynamo, for example, which is explained in the article. So it's a library for interacting. It's way smaller than the GitHub library. So it's a library for interacting with DynamoDB, Amazon DynamoDB, and there are just 5 interfaces or so. And there's also 5 fake classes, which help you to use this whole library in unit testing. And the one last thing which I wanted to explain is how to implement these fake classes. What should be inside them? How they work internally? It really depends on the situation. It depends on what's more suitable. For example, in DynamoDB, we're using H2 database, which in-memory database. It's not in-memory database only, but we're using H2 with in-memory database. So it's a quite powerful and lightweight Java database library, also open source. So when you create a fake DynamoDB object, then this object internally creates a fake, not a fake, but a real real H2 database in memory. And then when you call it and say, you call the DynamoDB object and say create a table and then put a record into the table, in reality it just saves this record into the H2 in-memory database. But you don't see it on the surface. You don't understand what's going on. You just assume that, okay, it just works. Like in this GitHub example, you don't know what's happening inside, because when you call and say create an issue for me and post a comment in there. But internally, there is an XML file there, and this XML file, yes. And when you create an issue, there is a few elements are being created into XML files, some attributes, some elements. When you post something, there's another element there. So it's always possible to see the entire snapshot of what we just created and how it looks. Just fake data. So we didn't do anything. We didn't do any interaction with the GitHub, but we created an XML file. And in this XML file, we have all these elements for issues, for pull requests, for stars, for users, for repositories, for everything in the XML file. So we just invented the internal structure of data to be used only for the purpose of these fake classes. So that's probably it. So that's what I wanted to say. My main point again is that this has to be responsibility of a creator of a library to ship to me as a user these fake classes, which will help me to automate my testing, to write my unit testing, to avoid mocking. Because we can't just avoid mocking and don't do mocking at all, which some people also sometimes say, okay, don't do mocking, don't do unit testing. Because you can't do unit testing without mocking. You can't just unit test without actually creating some replacements for the dependencies you rely on. So like I just showed, my class actually is talking to GitHub and I need to get a comment from GitHub, and then I do some processing internally, and then I post a response there. So in order to test my class, you need to give me something which looks like GitHub comment. So without mocking at all, it's just not possible to unit test this whole thing. We just go without unit testing, which is wrong. So the mocking or the mocking and replacing and breaking these dependencies, replacing dependencies with some fake or mocked or some replacements, this is mandatory. We just need it. But how to create these fake dependencies? That's the question. I'm in favor of fake classes shipped together with production classes, and strongly against the mocking libraries. That's what I wanted to say. You can ask the questions if you have. While you're typing them, let me look at the article on the blog and show you what are the most popular questions there. Yeah, there was one question where people saying that how about instead of shipping together the production code and fake classes, we can ship them separately in two separate, like, jars, or in two separate artifacts. I think this is it is less effective for a few reasons. First of all, because when you develop them, when you create a library, you develop your production classes and you develop your fake classes, then it's better to keep them as close to each other as possible, because they have to look very, very similar on the surface for the user. So if they stay separately, if they stay far away from each other in different libraries or in different artifacts, there's a higher chance that they will go different directions. And eventually you may, for example, one of them will start implementing some functionality in a different way than the other one. And then it will become useless to me, because I can't use fake classes if they are not really 100% behave exactly the way the production classes behave. So I would suggest to stick them, to keep them together. It's just more strategically, it's just more effective. Some people care about the size, like they say, okay, this is the production library with 100 classes, for example, in case of GitHub, and then you give me 100 classes for production code, and you give me 100 fake classes. So it means that they both will stay in production deliverable, in the production code, which I ship to the server or ship to the client. That's a valid question, that's a valid concern, but I'm in general in favor of maintainability and supportability and readability and just the speed of development and the easiness of development, comparing to performance and optimization of size and optimization of everything else. Because I believe that if you save a few megabytes on the final jar, and then it will cost me a few extra days of work to understand your mocking, then a few megabytes is way less important than the time I spent to understand the code, because this is way more expensive. So mocking, like I demonstrated, the mocking with the frameworks will make your code way less maintainable than using fake classes. So yes, this is the price we pay. We ship them together. They definitely take some space in our final artifact, because this is something extra which is not going to be used in production. But this is not a huge price to pay for the simplicity of development, for the clearness of code, I believe. One more question on the blog. Also very, relative to the question I just mentioned, is that people say that when you ship your production classes and together with the fake classes, there is a high probability that we by mistake, accidentally, we may use these fake classes in production instead of production classes. So that's true, that may happen, but I would say that sometimes even in production code, yeah, this is the first problem. It may happen. Yes, it may happen, but again, I don't see a big damage which we may cause by that, because these are just fake classes, and if you use them by mistake where the production classes should be, okay, your just code not gonna work. So you're not gonna break anything. You're not gonna damage your data. You're not gonna frustrate your users, because you're trying to, for example, you're trying to talk to the GitHub, but then you're posting some comments, and the comments are not going through because it's just a fake class instead of a real class. So you're just going to nowhere instead of the RESTful API. Well, how big is this trouble? I don't think it's going to be big. And at the same time, you just keep these classes in separate packages, and you name them properly, and then you don't make them available, all of them available public, so that in order to get access to these classes, you need to really go through some set of calls, like in our library. So I don't think it's a big problem. And I should say also that in some projects, I use fake classes in production code as well, not only in unit testing. And sometimes it's very convenient in a few situations. I just don't know where exactly you can use that, but in general, it's applicable. Like sometimes you use in production code, you may say like, in this case, instead of going to the real data, we can just use this fake set of data. So it's very convenient to have this kind of set of classes which you can use like supplementary instances of your interfaces. That's what I wanted to say. One more question, and we are done for the day. And this is the question about the I think I just answered that. Yeah, some people say that that's probably the last thing I want to say, is that sometimes mocking is really faster, and if it's just one method, and if it's just not a set of interfaces like I demonstrated in this library, but sometimes it's just a small interface or a small class and just one method, and the mocking will just take 1 or 2 lines, then why not using mocking library? That's true, but I think that if you start using mocking, because the people say that in order to create me this fake class, I need to create a new package, I need to create these fake classes, I need to create a few of them, they should interact with each other, I need to invent the mechanism of how to actually manage this fake data. It's some work to be done. Instead, just use the Mockito and just 2 lines or 4 lines, 5 lines, and you're done. So of course, creating this fake class is an extra job. Extra work, extra effort for the author of the library. That's definitely true. But you do this work only once. So you spend your time only once. You create this fake infrastructure, you create these fake objects, and then you just have them there. And all users, they will be able to reuse them, including yourself. So when you start thinking about using Mockito to mock something, just stop for a second and think, okay, am I the only one who's going to mock that? Am I the only one who has the need for this mock, for this fake instance to fake dependency? If you're the only one, I doubt it's going to be the case. I doubt you're going to be the only one. So in most cases, you should just stop and say, okay, I'm going to spend 2 hours instead of 15 minutes, but I will create the proper set of fake classes, and I'm going to use them instead of using Mockito, instead of using mocking frameworks. And that's how you make some extra effort up front, but then later your code will be easier to it will be easier to write all the unit tests. It will be just easier to continue the development. So this is some sort of investment into the future. So when you create a library, always think about how to create these fake classes, and don't start mocking, don't start using Mockito or any other frameworks. You better think about making the set of fake classes. This is the investment in the future, in the library. So that's what I wanted to say. We have one question here and a few more minutes. Let me read it. Yeah, so the question is that, this one. So the question is that if we have a hierarchy of interfaces in most cases. So like in this example, you just get a one object, and then from that object you get another one, then another one, then another one. So the question is that how about what if we want to get an object from the bottom of the hierarchy, the fake class, and just instantiate it and just use it. So I don't want, for example, that's probably the point. So I don't want to make the GitHub instance and then wrapper instance and then issue instance and then comment instance. So like 5 steps. I want to just create a comment instance, for example, only for the unit test or for the production code. That's how your fake, the fake part of the library has to be designed to enable that. So if you really want your customers to be really like flexible in using these classes, then yes, definitely you should allow them to make instances of any fake class you have. So like in the GitHub library, for example, we allow not all of them. We don't allow any of them to be created. So we always want you to go through the top level to the bottom. So it's to create the GitHub and then repository and then deeper and deeper and deeper. In the DynamoDB library, it's possible to create any instance of any object, if I'm not wrong, if I'm not mistaken. So it depends on the design of the library, how you want it to be used. The more flexible it is, the better. And I also think that in some cases, I've seen that, in some cases, the size of these fake classes can be bigger than the size of production classes. So they can be bigger, they can be more flexible, they may have more functionality inside, they may be just more complex than production. I think in DynamoDB that's the case, because actually to going through just making the HTTP, the SDK calls to Dynamo SDK is just 2 lines of code. But actually getting this data and saving into H2 database and converting from NoSQL to relational format, it takes some effort. And the amount of code is bigger. Because, like I said, because the most important thing for us as developers of the library is the convenience, how convenient it is to use for our users. And to use means not only use in production, but also in unit testing, because unit testing is more complex, usually more complex, more sensitive area of development, which needs more attention, which needs more instruments. And if the library gives you only tools for production code and doesn't give you anything for unit testing, and this library is way more difficult to use than the library which would give you something for unit testing. So these fake objects is how much you pay attention to the library, to your library, how much you pay attention for the library to be able to be used in unit testing. So that's probably it. Try to use them, try to design them. There is an article on the blog about it which explains briefly how it works. And I think it's going to improve the quality of your unit tests and your production code. Thanks for listening. See you next time. It's the first Wednesday of every month at 11 in the morning Pacific time. Thank you. Bye-bye.